Hi everyone, and welcome to the experimental video for the preparation of alum from aluminum cans. So what we're going to do first is we're going to obtain a piece of aluminum that is going to mass approximately 0.3 grams. So we'll have some aluminum squares for you out on the bench. You'll just have to find one that is about 0.3 grams. So once you have that, we're going to move on to the first step, which is sanding our aluminum. You're simply going to get a piece of sandpaper, your aluminum, and you are going to sand off the outer coating and the inner coating, which is on our aluminum pieces. So once you've sanded your piece of aluminum, we're going to weigh it out, and it's going to be just checking to make sure that it's about 0.3. So we're on step 2 now. So we're going to be cutting our aluminum into strips. If we create more surface area, we'll allow the reaction to go a bit quicker. So the next step is on the analytical balance. You're going to pre-mass a 50 milliliter beaker. You're going to want to make sure to put that weight of the beaker into your results section, and as the second entry there, the mass of the beaker. And this is on page 5. It is crucial that you start taking this information, because in order to calculate theoretical yields, we're going to have to keep track of this info. So you're then going to take your aluminum, which was sanded, and you're going to cut it up into a bunch of pieces in preparation for step 3. So I'm going to get this cut up and into my beaker. Once you've cut the aluminum into your little pieces, you're going to weigh the beaker again. And you'll record that entry onto your results section as well. And that's the top, the mass of the beaker and the aluminum. On to step 3. You can cut. So step 3 is going to be done in the hood because we're working with our potassium hydroxide, which is going to be reacting with the aluminum, which we've sanded and weighed out. So using 15 milliliters of 4 molar potassium hydroxide, we are going to react with our aluminum. Right up to 15. Now, since we're looking to speed up the reaction, we're actually going to be using a hot plate to help facilitate this. Normally, we'd leave it in the hood and swirl every once in a while without heat, but by adding heat, we'll allow it to react more and practice social distancing by not staying in the lab as long as we would have. So, I will now add my potassium hydroxide to my aluminum. This reaction gets very hot without the addition of heat from the hot plate, and you'll notice that we start to have the aluminum reacting, and you'll see bubbling. So this, with the added heat from our hot plate, this should take about 15 minutes total. So while our aluminum is reacting in the hood with the potassium hydroxide, we're going to move on to step 4, which is basically doing an observation of reactions with aluminum. So what you'll find on the lab bench is there's going to be 3 50 milliliter beakers. Now this is just going to be an observing thing. Your instructor is actually going to initiate this once you guys get the reaction going on the side. So what you'll find is 3 beakers, which will be used for the 3 reactions of the aluminum. And we're going to be reacting hydrochloric acid, 6 molar. We'll be doing 6 molar sodium hydroxide. And then we'll be doing water. Okay? So there will be 5 milliliters of each solution. there's water. Five of my acid. And then 5 of my base. So these beakers will be set out. And we will then drop in a piece of aluminum for you to observe the reactions. The size or mass of the aluminum doesn't matter because we're solely just looking at this for observation purposes. So those will be left here to react, and you'll check back in to see what exactly happens when we react aluminum with hydrochloric acid, water, and sodium hydroxide. Once you've looked at the reactions of aluminum and entered that information into the data section on your sheet, you're going to come back and check on your reacting aluminum. So here we can see that the reaction is getting definitely more vigorous as the potassium hydroxide attacks that aluminum. We're going to leave this for a little bit longer, and then we'll move on to the gravity filtration, step 5. Checking back in with our reactions, we can see we got some stuff going on here. Make sure to record your observations in the results section, and this is on page 4. Since we have the potassium hydroxide in excess, the reaction will eventually stop, which just happened. So we are going to set up a gravity filtration where we're going to filter our reacted aluminum and potassium hydroxide. In order to do this, we're going to set up a ring on our stand here. You're going to have a clean 50 milliliter beaker. So this is setting up our gravity filtration. I have my ring stand, I have my funnel, doesn't matter if it's plastic or glass, we just need it. Placing the filtrate into our clean beaker. Folding a filter paper in half and then in half again will give you your filter, and holding it in place will add our solution. This will allow your filtrate to come off and leave you with the impurities, which may be the outer coating, any dirt or impurities which were found on the surface of the aluminum can. So we're finishing up the first part of step 5 where we have filtered off any impurity. You're going to dispose of this in the front hood or in the designated waste beaker that your instructor tells you to. So we're going to get rid of that. And to our filtrate, we're going to add 8 milliliters of 9 molar sulfuric acid. Upon adding our sulfuric acid, we will have the formation of our alum. We're going to take our alum and let it sit on ice so we can allow that precipitation to occur. And then we will wash this and any excess. So we're going to allow this to cool for about 10 minutes as our alum is prepared. You'll want to mix with a glass stir rod. To allow for the formation.